Good morning, good evening, good afternoon, good day, mates. Here we're going on now to example number 1 for section 9.3. Oh, that's part B. Hold on. There we go. First one first, and then we'll do the second one. We're going to be using the nerdy skills that we learned in chapter 7 from Math 95, and that is when you learn how to add and subtract rational expressions. Rational means, again, fractions. Expressions means with variables. So fractions with variables, the nerdy way of saying that is rational expressions. Okay, so something that we've all learned how to do, something like if I said 1/3 plus 2/5, if we're going to add two fractions together, don't we have to first get our common denominator, known as the LCD, right? We have to get the lowest common denominator. And basically, you just say, okay, what does 3 and 5 have in common? Well, they both are multiples of 15, or basically they're factors of 15. So if I multiply this side by 5, and if I multiply that side by 3, now we have a common denominator of 15. Okay, so our lowest common denominator is 15. All right, so we've done stuff like that before. So we're going to use that exact same idea when we are going to be adding these guys together over here. Okay? All right, so when we solve equations now, we need to find the lowest common denominator first. All right? And the lowest common denominator, normally, you just take all of the factors that are in the denominator and you see, well, do they have anything in common right now? Again, this is x. This whole thing is x plus 2, not just an x by itself, but it's x plus 2. And then this is 1. So they don't necessarily have anything in common. So basically, if you just multiply them all together, that's going to be the LCD. So we'll have x times x plus 2 and multiply that by 1, but that doesn't change anything, so we can just kind of ignore that 1 there. So this will be our lowest common denominator. All right, x times x plus 2. And I got that by just looking at all the denominators, and I just basically just multiply them together. All right, so check this out here. What we're going to do right now is we're going to multiply everything by x times x plus 2. So I'm going to multiply this by x times x plus 2. I'm going to multiply this by x times x plus 2. I'm going to multiply this by x times x plus 2. All right, here we go. And you'll find out what the purpose of it, and you're going to be like, oh, dude, that's so nerdy. Okay, so let's do it. So x times x plus 2, and I'm multiplying that by 2 over x. Okay, right here, 2 over x. And then plus x, oops, don't need that little parenthesis there. So we have x times x plus 2 times 3 over x plus 2 equals x times x plus 2, and we multiply that by 1, but that's not going to change anything, but we can just go ahead and show that. We're going to multiply that then by 1. Okay, so notice that we took this exact same equation, so right here, bloop, 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 and next to every term we multiplied by x times x plus 2. All right? When you do the same mathematical operation to both sides of an equal sign, we're not changing the problem. It's the exact same problem there, okay? So, you ask, what's the purpose of doing that? Well, look at what happens here. See how there's an x in the denominator, and there's an x in the numerator. What the? Those guys can cross out. Okay, so that means now I have x plus 2 times 2. So let's go ahead and do the distributive property. So 2 times x is 2x. 2 times 2 is plus 4. Do you notice what happened to the problem? The denominators are gone. Oh, snappers! We were able to eliminate the denominator. Basically, there's no longer a fraction by multiplying by the LCD. Watch what happens again over here. See how there's an x plus 2? So, hi-ya, hi-ya. So now we have 3 times x, or just 3x. Oh, look at that. Fractions are gone again. Dang. Told you that was going to be nerdy. All right, and then right here, x times x plus 2 times 1. Just go ahead and multiply through this guy right here. So x times x is x squared. X times 2 is 2x. All right. Now we need to go ahead and solve this, and now we're going to use the skills that we have been acquiring in 9.1 and in 9.2, which is solving quadratics. And we could do that by factoring, by completing the square, by sometimes we could use the square root method, or we could use the quadratic formula. So it's just up to us now how we want to solve this. But we need to first put this in standard form. So I'm going to move everything to the right side. And the reason why I'm choosing to move everything to the right is because I want to have my leading coefficient to be positive. I don't want to move this over here and have a negative x squared, all right? So let's let's just first combine these guys together. And I get 5x plus 4 equals x squared plus 2x. So now let's move this 4 over here by subtracting 4 from both sides. And I'm going to move this 5x over here by subtracting 5x from both sides. Okay, so we get 0 equals x squared minus 3x minus 4. And what form is this called right here? Cricket. Standard form. Ah, very good. So we want this in standard form before we start to solve this. All right, well, I probably wouldn't try using the quadratic formula quite yet. Let's see if this can factor, right? We do our little judo. Put the last number on top. Put the middle number on the bottom. Tu numere. Now multiply and give us -4, and you add to get -3. So multiply up here and add. Well, I know 4 and 1. And then if I want a -4 up here but a -3 right here, wouldn't I put that at -4? -4 times 1 is -4. -4 plus 1 is -3. So that means my factors are x minus 4 and x plus 1, right? So right here. So in this case, we would not have to. We would not want to use the quadratic formula. It would be a bit of work, which is not necessary. So remember, we set each factor equal to 0. So I have x minus 4 equals 0. And then I have this guy, x plus 1 equals 0. So we add quattro to both sides. X equals quattro. Ay! Subtract 1. X equals negativo uno. Ay! And I think that gives us our answers right there. 4 and -1. And this right here was a nice extensive problem here, as you can see.